Welcome to video notes 8.2, Essential Skill H2, Analyzing Conics. The first thing we're going to do is take an equation in general form and convert it to standard form for whichever conic we have. Our main tool is going to be using completing the square. This first example, we're not told what type of conic it is, and so we're going to complete the square to find out. We're going to group all the x terms together, group all the y terms together, and move the constant to the right side of the equal sign. Now we have the equation in standard form. We can see that that's the standard form of the circle. So we can identify the center, the radius, and then graph it. And we're done. Example 2. We're given an ellipse, and this time completing the square is slightly more complex. Take a look. Now we can see that this is going to be an ellipse. We divide through by 4 in order to get that constant 1 on the right side. Now we graph. Our center is 1, -3. Our denominator indicates that in the x direction we're going to go 1 to each side. To up and down. Here's an example of putting a hyperbola in standard form by completing the square. Watch out here. We're factoring out a -9. Again, be careful that -9 is multiplied by 25. Now we can divide through by 9 and get standard form. From this, we can get our center and our x and y radii. Remember that to build a hyperbola, we draw a box, draw its diagonals, extend them, and use those as asymptotes. Now we identify which direction this hyperbola is going. The lead term is the x term. It is positive, so this is going to be horizontal. Our follow-up question is to find the equations of the asymptotes. We know that both asymptotes pass through the center, 3, -5, and as I was extending the asymptotes, I saw that I was moving over 3, up 1. Our slopes are 1/3 and -1/3 respectively. Our next example is finding the equation of ellipse that has given vertices. What we need to get the equation is the center and the x and y radii. So, the center is easy enough to find. We'll simply look at where the axes intersect. The x and y stretches, A from B, 2, and 3 respectively. And so our equation is just a matter of plugging in the numbers. Our final task is to identify conics. We can certainly do all the algebra of completing the squares and figure out what the shape is once we have it in standard form. Or we can get clues from the coefficients of the squared terms. Take a moment and read through this handy guide. Now we can apply this. In our first example, we have an x squared term and a y squared term, and they have the same coefficient. By the rules, this should be a circle. Let's see why. If we divide both sides by 4, we'll get standard form for a circle. Our second equation has two squared terms, both with the same sign, both positive, but one is different from the other. This will end up being an ellipse. In our third example, there's a difference of squared terms. One's positive, one's negative. That indicates a hyperbola. In our fourth example, there's only one squared term. It's x squared. That means that since there's a y term and an x squared term, this will be a parabola. Furthermore, we can see that it's going to be upright because we only have a y and an x squared. Our final example has an x squared term, a y squared term, and they're opposite signs. This will be a hyperbola. Our final topic is to look at the intersection of conics. To get a good idea of how two conics will intersect, we can see what the shapes are. Clearly, this is going to be a circle. This is going to be a hyperbola. Do they intersect? We don't know. That's the big question. Here's what could happen. We could have a circle. We could have a hyperbola. Maybe they intersect in 2 places. Maybe they intersect in 4 places. Maybe they intersect in 3 places. That is a possibility too. Or maybe they don't intersect at all. There could be anywhere from 0 to 4 points of intersection. To know for sure, we need to solve the system. Take a moment to recall some of the ways that we solve systems of equations. We solve them graphically, by substitution, or by addition. Another name you may know that last method by is elimination. Let's think about graphically for a moment. Are your graphs accurate? Are my graphs accurate? Sometimes they're not bad, but they are not accurate enough to read a radical solution from them. That leaves us 2 ways. You can use substitution, you can use addition. Either way works. Remember, from the graphic on the other page, we know that we can have up to 4 solutions. Those usually happen when you square root both sides and have a plus or minus. The first system has some x squareds and y squareds by themselves. That makes it ideal for substitution. I'm going to solve for y squared and then substitute into the equation below. This system has 4 solutions. X can be plus or minus 2, y can be plus or minus 1. So that means we have 2 comma 1, 2 comma negative 1. So this system has 4 points of intersection. This circle intersects this hyperbola 4 times. Let's look at the second example. Here I have 2 choices. I can substitute for x, or I can substitute for y. Think about what would happen if I substituted for y. This becomes a 4th power. We don't want to solve this 4th power equation if we can avoid it. So I'm going to substitute for x squared instead. Now, we have two different answers for y. We have to use each one independently, because they're not going to square to the same thing. So, I'll plug them in individually, and we'll solve for x. So again, we have 4 points. We just need to associate the correct x coordinates with correct y coordinates. Thank you.